Seismic faults in New Jersey suddenly emitting carbon monoxide gas. Indications of earthquakes coming? Is this possible? Well, this is what we saw in yesterday's video concerning the West Coast and what was going on there. But we're also going to take a look at the earthquakes on the Canadian map showing the recent earthquakes on the East Coast, which Seismic Berkeley doesn't show. And we're also going to take a look at the real-time Nullschool to see what the gases are like in that area. So the seismic faults in New Jersey. We even have volcanoes in Maine, 5 of them exactly. So this story is important because it turns out that something at least our readers should be familiar and warned about. 3 earthquake fault lines in New Jersey begun emitting carbon monoxide gas from underground, possibly indicating they're being squeezed and potentially warning of a coming earthquake. Satellite model using analysis from space is showing the carbon monoxide CO gas emissions in our atmosphere, and it corresponds remarkably well with the location of the Hopewell, Flemington, and Chalfont earthquake faults. And we have satellite data. We're going to see the Nullschool real live as well. Superstation 95 checked with the New Jersey State Police Office of Emergency Management to find out if there are any large forests or brush fires in the state, which might account for the larger than usual show of carbon monoxide. But they reported that the state has gotten heavy and steady rains for hours and no large fires of any kind taking place. That might account for the satellite reading of high carbon monoxide gas. Also, common sense says that there's little or no heavy industry operating lately, and of course no major traffic jams. So the question is, where is the carbon monoxide coming from? The answer is earthquake faults. Before going any further, we have to emphasize there's no scientific way to actually predict an earthquake, and we are not doing that. The article is published solely for information, informing the public about the factual matter that's taking place and the historical facts about what this might mean. So none of you should panic or get upset at what you're reading. Now, New Jersey has 4 main earthquake faults. The most well-known is the Ramapo Fault. The lesser known are the Hopewell Fault, the Flemington-Furlong Fault, and the Chalfont Fault. It's known as in the scientific community that depending upon the makeup of the ground beneath us, there have been some very few cases where carbon monoxide started coming out of the ground a week or 2 before an earthquake struck. And it happened in India. The most famous of these incidents took place in India. It was analyzed by Dr. Ramesh Singh. Earth emits a burst of carbon monoxide, CO gas, a few days before an earthquake, according to geophysicist Dr. Ramesh Singh. He and co-workers from France and the United States report that this gas could be used as one of the precursor signals for an earthquake early warning system. The scientists used data from the American satellite and analyzed changes in carbon monoxide at different altitudes. The carbon monoxide shows enhancement in concentration a few days prior to the earthquake, Singh explains. Singh, who was formerly in the Indian Institute of Technology in Kanpur, is now physics department of Chapman University in California, the USA. The project was funded by the Indo-French Center for the Promotion of Advanced Research in New Delhi. The researchers discovered the connection between CO emission and earthquake by analyzing satellite remote sensing data collected around the time when a 7.6 magnitude earthquake shook Gujarat in western India about 20 years ago. 20,000 victims of that earthquake and rendering thousands homeless. The 2001 Gujarat earthquake occurred January 26 at 8:46 a.m. In local time, lasted for over 2 minutes. The epicenter was about 9 kilometers south-southwest of the village of Chobari in Bachau Taluka of Kutch district in Gujarat, India. Singh said that the carbon monoxide levels were taken by an instrument on board NASA's Terra satellite launched in 1998. circling the Earth in the polar orbit at the height of 705 kilometers. The instrument measured CO concentrations at different heights and also computes the total amount of gas in a vertical column of air above the Earth's surface. Analysis of the satellite data showed a large peak in CO concentrations during January 19 and 20, a week before the main earthquake event. On January 19, a local CO in the vertical column was also higher than usual. After the January 26 earthquake, the concentration of the gas dropped. According to the scientists, CO gas is forced out of the Earth due to the buildup of stress prior to the earthquake, influencing the hydrological regime around the epicenter. Singh said an anomalous increase in land surface temperature a few days prior to Gujarat earthquake, as inferred from the data of NASA's other satellite MODIS, is also related to the CO emission. The increase, he said, of column CO and concentration CO may have enhanced the land surface temperatures. The anomalous change in CO concentrations prior to the main earthquake event and enhancement of temperature of the Earth's surface observed from MODIS satellite data give an indication of coupling between land and atmosphere, he said. Singh said observation by other researchers of a sudden increase in water vapor in the atmosphere and changes in the ionosphere a few days prior to the Gujarat earthquake all seemed to be connected. According to the report, all these observations included the latest discovery of CO emissions show the existence of a strong coupling between land atmosphere and ionosphere. The integration of all these parameters in a seismically active region therefore looks a potential approach to understand earthquake processes and may provide reliable information about an impending earthquake, the researchers concluded. It also happened in China. No other earthquake in the 20th century was as catastrophic or claimed as many lives as that which struck the city of Tangshan in northern China, July 28, 1976. Tangshan, a thriving industrial city in Hubei province, located about 95 miles east and slightly south of Beijing, and about 280 miles southwest of Haicheng, Liaoning province, where in February 1975, another very destructive earthquake had occurred. Although the region had experienced moderate seismic activity in the past, there were no foreshocks and no advanced warning. Magnitude was originally reported as 7.8, later revised to 7.6. There were no foreshocks or clear precursory phenomena towards Tangshan earthquake, as there had been in other earthquake-stricken areas of China. However, more than half a month earlier, there had been a series of abnormal signs observed in the region of Beijing, Tianjin, Tangshan, Bohai, and Zhaijiakou, and based on such signs, the State Seismological Bureau had correctly concluded that a significant earthquake could be expected between July 22, 1976 and August 5th. However, the precursory phenomena differed from those of other earthquakes because of the scattered distribution of the signals. There was no determination of the location where the earthquake would strike. Just prior to the earthquake, many unusual phenomena were observed in the intermediate Tangshan region. There were observations of large amplitude variations of groundwater level and of strange animal behavior. As early as July 12th, it was reported that gas began to discharge from a well in a village. On July 25th and 26th, this discharge increased. The day before the earthquake, well water at another village reportedly rose and fell 3 times, and other wells showed signs of cracking of their lining. Within seconds of the earthquake, people lost their lives or trapped in debris. And no prediction, just common sense, though. The article is not a prediction or some sick hoax. It's a logical assessment of the facts as they are known using data sources which are reputable and which form the basis for a logical conclusion. Quite simply, we have compiled the information to ask the reader to apply common sense. No reason to panic, but there is reason to pay attention and think if maybe we should make some preparations just in case. Now, let's go to the, having said this, it's undisputed that the last time this type of CO emission took place, it was the earthquake of 7.6 in India, and before that, the 7.6 in China. Let's go to the maps to see what's going on right now. Seismic Berkeley, and we only have earthquakes of this past week. Okay, these are earthquakes that we see here. Maine, as we know, has 5 volcanoes. 4 of them are in a 100-mile distance with each other. Another one here in Canada right next to it, and this around the area of Quebec. But going to the Canadian, this is the area of what we're going to look at right here. Okay, New York, Connecticut, New Jersey, this area right here. So let's go to our Nullschool. This is it right here. I'll leave a link below for you for this. This is the area that we're looking at. This is CO, carbon monoxide, surface concentration. Okay. Chemistry. Okay. Carbon monoxide, CO2, SO2, nitrogen. Okay. There we go. Let's go back to this. And we can go in. This is the area that we're talking about. This is the area that this is today. This is real-time satellite information data. Okay. So that's what's going on today. That's pretty strong. And that's the strongest in the United States that we see. Isn't that something? So please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.